All right, welcome back. So this will be part 2. We're going to look at a few more examples here. So use the activity series to write a chemical equation for each. If there isn't one, simply write no reaction. So again, we're looking for, is magnesium active enough to replace silver in silver nitrate? So again, we just have to look back at this activity series. So here's silver and magnesium. Ooh, it's way high up there too. So we can definitely say this reaction will happen. So silver will be out on its own, and magnesium, which is Mg2+, and nitrate, which is NO3 negative. I'll have to have 2 of those nitrates. So Mg, NO3, and I need 2 of them. It'll be in solution. So that's interesting. Solid magnesium, when it replaces silver, it becomes a magnesium nitrate solution. And then magnesium comes out. So we have to balance this. So we have 2 nitrates here. So we're going to have to put 2 nitrates there. That's also going to give me 2 silvers. So we have to put it here. And we can also say this is going to be fast because magnesium is higher up. Mg is quite a few spots higher than silver. Okay, so you can see it. So magnesium quite a few spots higher. Okay, zinc is zinc. So again, we're looking at the individual atom. The individual element, is it more active than the element that's part of a compound? So is zinc more active than iron? That's what we're going to look for. Is zinc more active than iron? Is zinc? Yep. Yep. So it is. Zinc is above iron, so it will replace it, but look how close it is. So it may be a slow reaction because zinc is just a little bit more active than iron. So iron, solid iron comes out of solution, and then we'll have zinc chloride. Just to check here, zinc is 2+, chloride's -1. So yes, we'll have to have 2 chlorides for every zinc. And let's see, 2 Cls, 1 iron, 1 iron, 1 zinc, 1 zinc. So we would say slow, since zinc is 1 spot above iron. So likely be slow because it's just a little bit more active. And lastly, nickel and aluminum. So is nickel active enough to replace aluminum? Let's see here. Is nickel above aluminum? Nickel, here it is right here. But unfortunately, aluminum is above. So zinc cannot replace aluminum. No reaction. So we can say nickel is below Al on the activity series. So there we go. That's how you do it. So not too crazy, not too difficult either. Let's look at reactions involving metals and water or acids. Not all single displacement reactions involve a metal in aqueous solution of an ionic compound. Sometimes the reactants are a metal and a compound that contains hydrogen, because you recall, hydrogen acts similar to a metal because it forms a positive ion when it gives up its electron. One of the most familiar hydrogen compounds are water and acids. So water and acids. The same procedure can be outlined above can be used here. We have some tips though. So think of something like HCl breaks down to H and Cl, so we treat it as an ionic compound. And water, a special case for water, just to make sure it turns out all right. So we can think of H2O as being made up of hydrogen ions and hydroxide ions. So we can think of the compound as being this. So here we have our metal and then our non-metal. So we can think of water as being HOH. It'll make things a little bit easier. So let's take a look. So using the activity series, write this balanced chemical equation for the reaction that occurs when lithium is added to sulfuric acid. All right, so lithium. So lithium solid plus H2SO4. So here we're looking to see again. So we can think of, here's our metal. Hydrogen over here is behaving like a metal. Then here we have our non. So we're looking to see, is that strong enough? Is lithium active enough? Is it a spot or two above hydrogen? So lithium, we'll see, oh, it's one of the most reactive elements. Hydrogen's way down here. So we can expect that to be a really quick, very fast and violent reaction because of that difference that we have here. So yes, we'll have hydrogen off by itself, and of course hydrogen is a Hofbrinkel, a diatomic gas. So all those ones that we have for that. Lithium is +1, sulfate is 2-, so yes, we'll have to have 2 lithiums to balance 1 sulfur. So 2 lithiums to balance 1 sulfur. And if we look here, 2 H's, 2 H's, 1 sulfate, 2 lithiums, and then 2 lithiums. And so we can say very fast, because lithium is so much higher than hydrogen. Let's continue on here. Look at this example. Use the activity series to write a balanced chemical equation for the reaction that occurs when sodium is added to water. And again, think of water as being HOH. We have a metal part and a non-metal part. So sodium added to HOH, water. And water is just, well, water, we don't put AQ here. Water is just water. There's nothing dissolved in it. So let's see here. We're looking for, we have our metal here. We have our hydrogen, which is acting like a metal. And then we have our non-metal. So is sodium active enough to replace H? Is sodium above H? There's a Na and H is down there. So look at that. Not as violent as the other reaction, but still, it'll be a fairly fast reaction. So hydrogen, so sodium kicks out hydrogen. Hydrogen's a Hofbrinkel. And then sodium and the hydroxide, 1-to-1. Easy. So 1 sodium, 1 sodium. 2 and 2, but oh, we have our hydrogen here. And we'll run out into a problem here because water will always give me 2, 4, 6, 8 hydrogens. So I have an issue with this when we're over here. The sodium hydroxide is always going to give me an odd number of hydrogens. So a little trick to balancing that is to place a 2 in front of the compound that is going to give you an odd number of H's. So now I have 2 plus 2 is 4 hydrogens. So if I put a 2 here, I'll get 2, 4. And then 2 oxygens, 2 oxygens. So there we go, it is balanced. All right, so if we take a look here, what you may want to do is pause the video and try these ones now. So again, we can take a look here. We have metals here, and we have hydrogen here, which is acting like a metal. So we can think of, will calcium replace hydrogen? Will copper replace hydrogen? Will barium replace hydrogen? Mercury, etc. So we can work out that same part there. So maybe pause the video and then come back and see how you did. Okay, so hopefully you had time for that. So calcium, is calcium above H? There's calcium. There's H. Oh, it's way above. So hydrogen will be off on its own as a Hofbrink element. And calcium bromide. Bromide's -1. Calcium's +2. So yes, we need to have 2 bromides to make this work. So that's 2 bromides. I'm going to have to put a 2 here to give me my 2 bromides. 2 H's, 2 H's. Good. So that is going to be fast. Copper. Now again, let's think of water as HOH, remember. Okay? And down here, HOH. So will copper be active enough to replace hydrogen? So, oh no, copper is below hydrogen. copper is below hydrogen, so there'll be no reaction. And we can just simply say Cu is below hydrogen. Okay? Barium and hydrogen. So barium and hydrogen. Oh, there's barium way, 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 way up there. Hydrogen's way, 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 way down here. So that'll definitely happen. So hydrogen will be kicked to the curb here. And barium and hydroxide. So barium is this. Hydroxide is -1. So yes, I'll have to have 2 hydroxides to make that work. And if I look here, let's see what I got going on here. I have 2 hydroxides here, I have 1 hydroxide. So I'll put a 2 in front of that. So that'll give me 2 2 OHs, and 2 Hs. 2 H's and 2 OHs. 1 barium, so that is balanced. And I can say that is fast as well, because it will be, because barium is so much higher. Mercury and hydrogen. Mercury and hydrogen. Let's see. Mercury. Oh, mercury is below hydrogen. So that won't work. So no reaction. And I can say Hg is below H, unfortunately. All right, I think we'll call that video quits, and then we'll come back on the 3rd and final video for single replacement reactions and talk about the halogens.